Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from summer 2022. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 20 to 23, which account for 20 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 20. The diagram shows a parallelogram ABCD and the diagonal AC. So ABCD is our parallelogram and AC is the diagonal that goes from A to C. The diagram's not drawn to scale, so that means we can't measure anything directly from it. And it wants us to tick 2 correct statements. So we've got 6 statements here, but only 2 of them are correct based on this diagram here. Now all of these statements are linking to angles, sides, etc. So I'm just going to start by labelling on the parallelogram what I know. So I know that this side and this side are equal. They're also parallel. This side and this side are equal, also parallel. Okay, so let's have a look at this. Angle ABC is not equal to angle CDA. So when we're dealing with angle notation, that middle letter is at the point at which the angle occurs. So ABC, ABC. So they're saying that this angle is not equal to CDA, which is this angle. Well, they're opposite angles in a parallelogram. That is not true. Okay, so that's not a correct statement because they would be equal. Next one, AB equals DC. AB equals DC, that's correct. AD equals BC. AD equals BC, that's correct. And AC is a side of both triangle ABC and triangle CDA. So ABC, it's the longest side, and then CDA is the longest side, so that statement is true. Next one, triangle ABC is similar to triangle CDA with enlargement scale factor 0.5. So ABC is similar to CDA with an enlargement scale factor. So that means one of them would have changed size. Well, that's not the case, is it? So that's not a true statement. Next one, triangle ABC is congruent to triangle CDA. Congruent means the same, exactly the same, lengths, everything. That's correct there. Oh, so it's not congruent, sorry. Is congruent. So not congruent is false. Is congruent is true. And then the last one, let's double check. We've ticked 2, but let's just double check we're not going wrong somewhere. AB represents the shortest distance from B to AC. So AB is the shortest distance from B to AC. Well, that's not correct, is it? That's not how it works. So we've got our 2 statements ticked there. Question 21. The diagram shows a cone placed with its circular base on a table. So there's the base of the cone on the table. It has a base radius of 15 centimetres and a height of 30 centimetres. Work out the volume of this cone. Give your answer as a multiple of pi, which is handy because this is a non-calculator paper. Okay, volume of the cone. We need to do 1/3 multiplied by pi, multiplied by the radius squared, multiplied by the height. So let's substitute in what we know. So we have 1/3 multiplied by pi, multiplied by, we want the radius squared. So the radius squared would be 15 squared, multiplied by the height, which is 30. You're going to get your first mark, guys, for substituting in the values that you know to the formula for the volume of a cone. Now we're going to do a little bit of simplifying. So we've got 1/3 multiplied by pi. 15 squared is 225 times by 30. So I'm going to do 225 times by 30 over here. So 0 times 5, 0 times 2, 0 times 2. 0 placeholder because we're moving into the tens. 3 times 5 is 15. 3 times 2 is 6 plus 1 is 7. 3 times 2 is 6. Add those together. So we've got 1/3 multiplied by pi multiplied by 6,750. Okay, we've got 1/3 multiplied by this. I'm going to do 6,750 divided by 3. Somewhere 3, 6, 9, 12, 15, 18. So 3's into 6, 1, 2, no remainder. 3's into 7, 1, 2, remainder 1. 3's into 15, 1, 2, 3, 4, 5. Then that 0 is going to get carried up. So it's 2,250. So we have 2,250 times by pi. So that's 2,250 pi. Part B. On the 1 centimetre grid opposite, so we've got a 1 centimetre grid on our next page, make an accurate scale drawing of the plan and side elevation of this cone using the ratio actual cone to scale drawing is 5:1. So let's work with this ratio to start off with. The actual cone is 5 times bigger in real life than in the scale drawing. So let's figure out what our radius and height are going to be. So our scale drawing radius is going to be 15 divided by 5, which is 3 centimetres. And then our scale drawing height is 30 divided by 5, which is 6 centimetres. So we've got a radius of 3 centimetres and a height of 6 centimetres. And we're going to use that information to draw on this plan here. So I'm just going to actually write it up here. Radius equals 3 centimetres, height equals 6 centimetres, just to make my life a little bit easier. Okay, so we're going to start with the plan. So the plan is the view that you get of the shape when you're looking at it directly from above. Okay, so this is a cone. So if we were to look at the cone directly from above, we're going to see a circle. All right, a circle with radius 3 centimetres. So I'm going to take my ruler and a compass and I'm going to measure 3 centimetres, and it doesn't matter where, but anywhere on here. And if you just double check, because sometimes copying of exam papers makes things a little bigger or smaller, change the size slightly. So it's 1, 2, 3, because it's a centimetre grid. And I'm going to draw that circle, guys. So that is the plan of the cone. That's what we would see if we were looking down onto the cone directly from above. Okay, the side elevation then, guys. So the side elevation would be what you see when you look from the side in this direction. Well, you'd see a triangle, wouldn't you? All right, and that triangle has a height and the radius would be halfway across the base. So for this side elevation, the diameter is what we're interested in here, because that would be the base of the triangle. So that's 2 times the radius. So the diameter is 6. The height is 6, so we're actually working here with potentially an isosceles triangle. So what we need to do, the diameter is the base of our triangle. So we're going to go 1, 2, 3, 4, 5, 6. And then we want a height of 6. So we're going to go from the middle here, 1, 2, 3, 4, 5, 6. And that's where we're drawing our shape for the side elevation. Question 22. A tank contains 225 litres of water. A tap at the bottom is open so that water flows out at a constant rate of 5 litres every minute until the tank is empty. Part A. On the graph paper below, draw a line to show the volume of water in the tank at any time after the tap has been opened. So the key here is a line, so it's a constant rate of water flowing out of the tank. So we're going to have a straight line here, guys. But what we need to notice is that actually we don't have any scale here. Now, the tank starts with 225 litres of water. So we need our scale to go up to 225 litres. So let's have a think about how we could do that. So we've got 1, 2, 3, 4, 5, 6. Okay. So if we went 50, 100, 150, 200, 250, that would work. So you got 50, 100, 150, 200, 250. Okay, let's go with that. It doesn't matter that we've gone slightly over, but what helps with this scale here as well is from 0 to 50 is 10 little squares. 50 divided by 10 is 5. So each little square is worth 5. And actually, 5 litres of water every minute. So that really helps us out. So when the tank is full at the start, we've got 225 litres of water. Okay, so at 0, so times 0, 225 litres of water. That's where we're going to start, okay? And then we lose 5 litres every minute until the tank's empty. So if we get to 10 minutes, we've lost 5 minutes for every, we've lost 5 litres for every minute. 10 times 5 is 50. So we would go from 225 to 225 take away 50, which would be 175. And then for the next 10 minutes, if we go down another 50, we'd go to here. And then for the next 10 minutes, we'd be here, and then the next 10 minutes here, and so on. So we're going to take our ruler. Obviously you'd be doing this in pencil, guys. I'm going to do pen just so you can see nice and clearly what I'm doing here. So I've marked on the points that follow the trend of this graph, and then I'm going to draw the line. Now we'd expect the line to go down because this tank is emptying, so it's starting up here and then it's emptying. Okay, so that's part A. We've drawn our graph. Part B, how many minutes does it take for the volume of water in the tank to decrease by 40% of the original volume? Okay, so we need to find out what 40% is. So the original volume is 225 litres, so we want 40% of 225. So we can find 10%. To find 10%, we divide by 10. So 225 divided by 10 is 22.5. I want 40%, so I can multiply my 10% by 4. So I'm doing 22.5 multiplied by 4. Well, 22 times 4, that's going to give me 88. 0.5 times 4 is going to give me 2. So that gives me 90. Yeah. So 90 is 40% of the volume. We're decreasing by 40%. So 225 take away 90. So that's 10, 100, 135. So we want to know how many minutes it takes for it to get to 135 litres. So let's figure this out. 150, 125, 130, 135. Remembering each little square is worth 5. So we're going to go along to our graph. When we meet our graph, we're going to read down and we're going to read off that time there. Again, you'd be doing this in pencil, guys. I'm doing it in pen so you can see it clearly over the grid. So we've got 10 to 20 is 10 squares. So each square is 1, 11, 12, 13, 14, 15, 16, 17, 18. So nice and clearly, I'm going to put 18 minutes and circle it so that I know that that is my answer. Question 23. The probability that Kathy cycles to work on Monday is 0.6. If she cycles to work on Monday, the probability that she cycles to work on Tuesday is 0.3. So if she cycles to work on Monday. If she does not cycle to work on Monday, the probability that she does not cycle to work on Tuesday is 0.1. Complete the tree diagram. Okay, so what's useful for us to hear? I know that seems for us here, so I know that seems a little bit confusing, but actually they've done us a solid because we've got at least one part of each of these branches filled out. Okay, so that's helpful to us, guys, because these branches have to add to 1 for probability. So the probability that she cycles to work on Monday is 0.6. So the probability that she doesn't cycle to work on Monday is 1 take away 0.6, which is 0.4. Okay. The probability that she cycles to work on Tuesday, if she cycled to work on Monday, is 0.3. Probability that she does not cycle is 1 take away 0.3, which is 0.7. Okay. So if she does not cycle on Monday, the probability that she cycles on Tuesday we need to fill in, but the probability that she doesn't cycle on Tuesday is 0.1. So 1 take away 0.1 is 0.9. So that completes that branch. They have to add to 1, guys. Part B, calculate the probability that Kathy cycles to work on both Monday and Tuesday. Okay, so when we're working with probabilities from a tree diagram and we're following a journey across a tree diagram, we're going to multiply, guys. So cycles to work Monday and Tuesday. So cycles on Monday is 0.6, cycles on Tuesday is 0.3, and we have to multiply those together. Okay, 0.6 multiplied by 0.3 is 0.18. If you weren't sure about that, let's multiply them both by 10. That's 6 times 3, which is 18, but then we'd have to reverse both of these multiplications. So we divide by 10 and divide by 10 again. So that's our answer. Part C, calculate the probability that Kathy does not cycle to work on either day. So does not cycle Monday and does not cycle Tuesday. So does not cycle Monday, 0.4, and we've got the multiply, does not cycle on Tuesday is 0.1. 0.4 times 0.1 is 0.04. Okay, 4 times 1 is 4, and I need 2 decimal places.